Today we are going to discuss the different lung volumes. So before we get into the details of lung volumes, you have to keep in mind two different terms, that is inspiration and expiration. So inspiration is taking in of air and expiration is, getting the air out of your lungs. So both these processes, inspiration and expiration together comprise what we call as breathing, right? So whenever we are taking some air in or giving some air out, we are doing it in a certain amount, right? So if, for example, you take 300 milliliter of air in and give 200 milliliter of air out, so this milliliter, this amount, is basically the volume of air that you will inspire or expire, right? Now your lung have different lung volumes, the volume of air that you can inspire or expire. The first volume that we will discuss is something known as tidal volume. So when you're breathing normally without any external force or without any intentional force, like if you're not breathing forcefully, if you're breathing normally like I'm breathing right now, that is your tidal volume. So tidal volume is the volume of air that is inspired or expired with each normal breath, like I'm breathing right now, right? And this is equivalent to around 500 milliliter of air. So normally when you're not doing any strenuous work or when you're not doing anything like that in which you need some extra force to inspire or put out extra force to expire, that is the amount of air that you normally breathe with each normal breath. So that is equivalent to 500 milliliter per minute. So that is your tidal volume. Moving on to your next volume, it is something called inspiratory reserved volume. Now to understand this volume, imagine going for a long run, right? If you're out for a long run and then you start breathing very deeply because you need that extra oxygen to come into your body, right? So you don't breathe like I'm breathing right now. You take in deep breaths, right? So you go something like this. So this extra amount of air that you're breathing above the 500 milliliter that you normally breathe with each normal breath is known as your inspiratory reserve volume, which is equivalent to around 3000 milliliter per minute. So this is the amount of air that you breathe over and above your tidal volume, the normal volume that you breathe with normal breaths, right? So this is your second volume. The third volume is the opposite of inspiratory reserve volume, which is your expiratory reserve volume. So this is the amount of air that you will expire after you have expired your tidal volume. So after you're done expiring your tidal volume, your normal breath volume, you give out the extra amount of volume that you could give out with as much force as you can. So it is something after the expiration of a tidal volume. So if you're done expiring your tidal volume and then you put on some extra effort, like you go like this, right? That is your expiratory reserve volume. The last volume that is something that we're going to discuss, and your expiratory reserve volume is equivalent to 1100 milliliter per minute, right? Moving on to the last volume, that would be your residual volume. So your lungs never are not ever empty, right? After even you have expired your expiratory reserve volume, you still have some amount of air left in your lungs, because if there is no air left in your lungs will literally collapse, and you don't want that, right? So the residual volume is the amount of volume that remains in your lung after you have expired your expiratory reserve volume. So even after you're done with your expiratory reserve volume, there is still some amount of air that is left in your lung, and that will form your residual volume, which is actually equivalent to around 1200 milliliter per minute. Now let's summarize the entire topic with the help of a graph, and let's see if it makes sense to you. So we draw a y-axis and we draw an x-axis, and let's see. So if this is around 500 milliliter per minute, right? So you're breathing normally, you're breathing normally, you're breathing normally. This is a tidal volume, right? And then you go out for a run, for example, and now you have to breathe in some extra air. So you use your lungs, you kind of expand your lungs more and take in all that extra air. So this up here is your inspiratory reserve volume, right? So this up here is your inspiratory reserve volume. And now you move on and expire some more air out, right? And this right here would be your expiratory reserve volume, and then you can go ahead and breathe normally, right? So this up here is your tidal volume. The extra breath that you took would be your inspiratory reserve volume. The extra breath that you gave out after you're done expiring your tidal volume would form your expiratory reserve volume, and then you can go ahead with the tidal volume. Now this amount of air that is still left in the lung after even you have expired your tidal volume would form your residual volume. So these are the different lung volumes that are normally encountered in a setting. All these lung volumes can be measured by spirometry except for your residual volume, because you never expire this out, so the spirometry won't be able to mention it. This is a high yield point. The rest of the volumes you can measure by spirometry. I hope this was helpful. Thank you so much for watching.